Okay, so these notes are going to be about writing equations of parallel, and then we're also going to do perpendicular lines. So our instructions say, write the equation of the line passing through the point -1, 1 that is parallel to the line y equals 2x minus 3. So what you need to know first about parallel lines is that parallel lines have the same slope. So anytime two lines are parallel, that means they have the same slope. So I'm just going to add this as a note down here. So these have the same slope. So we have an equation y equals 2x minus 3. So if I'm writing an equation parallel to that line, all I need is the slope from this. So you hopefully remember that in y equals mx plus b, that m is the slope. So step 1 says find the slope, or m, of the parallel line. Well, parallel lines have the same slope. So the m, or slope, of this line is 2. So the slope of our line that we're going to write is going to also be 2. So I'm taking that slope right there, and that's going to be our m. So our m is going to equal 2. The second step says find the y-intercept, or b, using the slope m and the xy. So remember that this is an x comma y. We're writing an equation in y equals mx plus b. We have no idea what the b is. That's what we're looking for, is what is our b, or our y-intercept. But what we do know is a y value, an m value, an x value. So we can replace each of those with a number and then just be left with the b variable so we can solve for it. So that's what we're going to do. We're going to plug in our y, m, and x. So our y is 1. Right here, our y is 1, is equal to the m that we are going to use is 2 because we're writing a parallel line, so 2 times x, right? Mx means m times x. We're going to plug in our x right here. Our x is -1. Close your parentheses, plus we're left with the variable b. Since we're left with just the variable b, now we can solve this for b and figure out what is our y-intercept. So to solve this, we first get rid of the parentheses by multiplying. So we have 1 equals 2 times -1 is -2 plus b. And then my last step to get b by itself is to get this -2 to the other side of the equal sign. So to do that, you do the opposite of a -2. So the opposite of -2 would be to add 2. So we add 2 to both sides. So the -2 and +2, those cancel. That's a 0 pair. That's what we wanted to happen. On the left-hand side, we have 1 plus 2 is 3. Bring down your equal sign, and we're just left with b. So b equals 3. So we can now write our equation in y equals mx plus b because we know that m is 2, and we know that b is 3. So we're just going to replace m and b with 2 and 3. So our equation of our line is going to be y equals 2x plus 3. So step 3 says to use a graph to check your work, and I would absolutely want you to do this. I don't necessarily think you need to use a piece of graph paper. If you don't have a calculator, then sure, you want to use graph paper, but I really am going to focus on using our calculator to check our answer. So the first thing I'm going to do is I'm going to graph this equation that we got, that we said is parallel to this line, and goes to the point -1, 1. So we're just going to confirm those two things. Is it parallel, and does it go through the point -1, 1? So in my calculator, I'm just going to scoot this over a little bit so we can see both of these at the same time. In my calculator, I'm going to add a graph page. So I'm going to do a new document. I'm going to add a graph. Remember that f of x, this says f of x, is the same thing as y equals. I don't have to delete that to change it to a relation. I can just leave it like this. So y and f of x are the same thing. So I could essentially just write this as f of x equals 2x plus 3. Those are the same thing. So I'm just going to leave this. I accidentally scrolled all the way to 21. There we go. So f of x equals 2x plus 3 is my equation. So there it is. I'm going to trace. So remember to trace, we do menu, trace, graph trace. Always starts out at our y-intercept. Our y-intercept is 0, 3. That should make sense because that's what our b, right here, we said our b is 3. So our first coordinate should be 0, 3. That's our beginning, or our y-intercept. We want to trace, though, to -1. I want to see, does this point match my line? So I'm going to go to -1. So remember, you can just scroll there to the left, or if you just type. So I start typing -1, it pops up on my screen. So there it is, x equals -1. I'm going to say enter. Yes, I want to go to where x is -1. There it is, -1, 1. So we know that the point is correct. So our line does go through the point they told me it should. The second thing I need to check is it parallel to y equals 2x minus 3? We should already know that it's parallel. It has the same slope, and we should know that parallel lines have the same slope. But just if you need to visually see that, you can graph it also. So to graph another line, we're going to push tab. So f of 2, this is my second line, that's why it's 2. So f2 of x, we're going to graph 2x minus 3. And there it is. And you can see that these two lines are parallel. Just another reminder, if you need to move these labels, you just click and hold, and you can drag them away from each other so they're not overlapping. So our slope here is 2, our slope here is 2. That tells us that they're parallel, but also visually seeing that they both look parallel should help you confirm that. Okay, so let's look at then how to do the perpendicular. So parallel have the same slope. Perpendicular do not have the same slope. So writing the equation of a perpendicular line. So a perpendicular line has a slope that is the opposite reciprocal, which sounds really complicated. So perpendicular, I'm going to add my note down here. These are opposite reciprocals. So opposite means positive and negative. So if the slope that I am given is positive, then I'm going to write an equation with a negative slope. If the slope I was given is negative, I'm going to write an equation with a positive slope. So opposite just means positive and negative. Okay? A reciprocal is when you flip a fraction over, basically. So let's say I have the fraction 2/3. Its reciprocal is 3/2 or 3/2. So reciprocal means to flip it. The most important thing about perpendicular is it has to be both of these, both an opposite and a reciprocal. If it's only the opposite or only a reciprocal, it's not going to be perpendicular. They're just going to be intersecting. So it has to be both opposite and a reciprocal. So our instructions say write an equation of the line passing through the point 2/3 that is perpendicular to the line y equals -2x plus 2. So -2x plus 2. So again, you should remember in y equals mx plus b that m is the slope. So that slope right there, -2, is what I'm going to use to find my new slope. I'm going to find its opposite reciprocal. So I'm going to take that -2, and I'm going to find its opposite reciprocal. So the opposite reciprocal is going to be a positive, because the opposite of negative is positive. When I flip that over, it becomes 1/2. So let me just clarify for a second. That was just a 2, and not -2 actually. That's technically over 1. We don't write that because -2 divided by 1 is just -2. But technically it is divided by 1. So I can flip that over and put the 1 in the numerator and the 2 in the denominator. So my new slope for my perpendicular line is going to be 1/2. So 1/2 is going to be my m. Okay. Step 2, just like on the previous example, find the y-intercept or the b. So our b is what we're looking for by using the slope, which is m, and the x, y, 2, and 3. So this is my x and y. So again, we're using y equals mx plus b. We're going to plug in the numbers we do know, which will allow us to solve for b. So we know that y is 3. This y right here is 3. Equals, our new m is the opposite reciprocal of -2, which would be 1/2. So m is going to be 1/2. Times, in parentheses, our x is right here at 2 plus b. So now we're just going to simplify. We're going to get rid of these parentheses first by multiplying. So 1/2 times 2 is like half of 2 would be 1. So 3 equals 1 plus b. Then your last step is to get this 1 to the other side, so we get b by itself. We want to get all these constants together. So we're going to move this 1 to the other side. We do that by doing the opposite. So the opposite of a positive 1 would be a minus 1 or a negative 1. So 3 minus 1 is going to be 2 equals, these are a 0 pair, so they cancel, b. So b equals 2. So our equation now, using our m of 1/2 and our b of 2 that we just solved for, is going to be y equals 1/2 x plus 2. And again, we're going to use our calculator graph to check that. So I'm going to first graph this line, the answer that we got. We want to make sure it goes to the point 2, 3. If it does not, we did something wrong. And then the second thing I'm going to check is it perpendicular to the line that they told me it should be perpendicular to? So I'm going to first start by graphing y equals 1/2 x plus 2. So I'm going to just add a new page. So Control Doc adds a page. We're going to add a graph. So I'm graphing my equation was 1/2 x plus 2. So there it is. Again, I'm going to trace. So to trace, it's menu, 5 is trace, 1 graph trace. So there's our y-intercept, 0, 2. We're looking to see, does it go through this point, 2, 3. So you can scroll, but it's much faster if you just type the number 2. So it's saying right here, do you want to go to where x is 2? I'm going to enter and say, yes, I want to go to where x is 2. There it is, 2, 3. So that matches what is on our paper. And then the last thing we're going to do is graph this line, also the original line, and we want to see that they're perpendicular. So I'm going to graph y equals negative 2x plus 2. So to do that, I'm going to push tab. So now I'm going to graph negative 2x plus 2. So there it is. So these are definitely perpendicular. You can see that that creates a right angle. If you're not sure, the slopes again tell us that if this is 1/2, its opposite reciprocal is negative 2. If this is negative 2, its opposite reciprocal is 1/2. So the slopes tell us that these are perpendicular, but they also look perpendicular. They're creating a right angle. Can't always go just based on how it looks, but that's a good start at least.